appreciate this interface between science and policy, and some of you who think about that, how difficult it is. I also wish I could get up here and tell you gaps in water data. We're good. Fine, nothing. We're all, thank you. But it's so big. There's no way that I could be comprehensive here. Not even after if I had a career in Washington, much less. So I thought I would tell you some things that I've observed that seem to be important in this. So just in the architecture of the talk in the next few minutes, we'll be going collect, standardize, integrate. Collect, standardize, integrate. Our vocabularies differ here a little, but I think we've heard a lot of this already this morning. Turns out there are gaps at each of these levels in water data. And again, a survey of some of the highlights, a little journey through some of those. So, first, a precept that I've been fond of using for years in USGS. I'm fond of saying that our data are collected to serve some need of society. They're not collected for their own sake. We're not in the data manufacturing business here at USGS. I gotta confess, I can't make last-minute changes to these slides. My precept is challenged by some of the things that we've heard here today. Perhaps it's more precise to say our analyses of data are to serve some need of society, but clearly data can be collected in a lot of different ways, including what we call data exhaust, which is just happening incidentally. So I'm in the process of reconsidering one of my long-held established beliefs. So let's start. We'll move from left to right. You see at the top of the slide here. Collect, standardize, integrate. Start with collect. That's the blue there. And I thought since gaps could be such a depressing topic, let's start with a success story. The number one question I hear that we get in the elevators, so to speak, how's the stream gauging network doing? We're known for our stream gauges, right? And my answer might be, wow, I'm so glad to be in this elevator. But I would reframe it as how is the water resources monitoring network? That's the more general thing. In the 21st century, we appreciate the continuity between surface water and groundwater, the hydrosphere and the biosphere, the one continuity. So how is the water resources network? Well, in some places it's actually pretty good. The surface water network, which we've had for a long time in our country, is stable. We get a lot of good information. Could it be better? Be better. But, dig a little deeper, how is this network built? This is an example of the federal priority stream gauges. This is federal funding in whole or part to our stream gauges. You'll notice the network drops off a lot. It's still got decent coverage, but all the other dots in the network are some composite of federal or of state, local, county, other sources of funding. It's a cooperative venture that USGS does. That lends a certain instability to it. Long-term data can be harder to establish. But fundamentally, I do consider this a success story. Now, on to digging further into that map. Gaps, right? First gap that I just feel beholden to say is about groundwater data. Groundwater. Pause and reflect for a moment that about half of this country's water supply comes from groundwater. And people who are self-supplied in more rural areas, about 100% of their water supply comes from groundwater, roughly. And yet, it is under-monitored. Aquifers are not well characterized at a large scale. There's a lot of room for improvement here. I purposefully chose a diagram that brings us into stark relief. This is an example of yesterday's climate response network built by the USGS. Sort of a more recent endeavor, but the goal here is to subtract away the effects of humans on the ground, how they might be affecting aquifers, and just look for that climate signal effect on groundwater supplies. And speaking as a recent resident of Arizona, I think I can say we need probably more than 3 wells in Arizona to monitor climate signal in the groundwater. So, more basic data, you bet. moving just sort of still in the realm of collecting data, but a little more synthesizing of it, is water use data. I'll come back to this a little later as we move up this whole hierarchy. There are even bigger questions about water use, but fundamentally that on-the-ground data collection gap here. It's a state-by-state, highly variable phenomenon. How much water is used on fields? Well, it's hard to know that. There's some promise in remote sensing, of course, and there's also a lot of innovation. I'm calling out one example in Arizona, where I'm from. There's actually survey-based. It's a combination of GIS, remote sensing, and on-the-ground surveying of crop fields, some modeling to come up with water use. Also the irrigation method. You see flood irrigation on the right over there, which is popular in some areas. But fundamentally, this is nationally inconsistent. So a national sense of our water use at that data level is a gap. And why would something like that be a gap? Well, I thought I would tell you. I'm just now noticing how many of my stories are from Arizona. It's like I am playing. So this gets back to the, do people want to listen to what what policies I have to say? So in the Verde Valley of Arizona, it's this beautiful perennial stream that flows through there. You can see it here. The residents of that valley have built a culture around that stream. Since just after the Civil War, they built these gravity-fed irrigation ditches, and they flood irrigate their lawns. And they have water rights under Western water law to that water. Well, it turns out it's not entirely clear that it's in a property owner's best interest to know how much water they're using because of the so-called use it or lose it problem in Western water law. With an allocation, if you show you're using less of it, well, you might not keep it all. So I'm just bringing this up to show it's complicated. Just because the data is out there, it's not therefore implicit that everyone wants to share it with you. So irrigation, what time of day I take my shower, it's not clear that people want to share that with any entity, much less a government, much less the federal government. So what can we do with basic data at this collection stage? Well, a lot we can do, but I thought I would just touch on one that in USGS, and of course in this room too, with citizen science, it seems to be a big untapped potential and we don't know what to do yet. There are some ideas here. I'm calling out here the earthquake in August of 2011 here on the East Coast. Can you raise your hand if you felt that? Did you go through that? So a lot of people felt it. So the USGS, our most successful citizen science program, is Did You Feel It? We had 144,000 crowdsourced responses to that earthquake, and it built this map. This is a shaking intensity map, which is not the same as an earthquake magnitude map. This gets to the more subjective dimension, building damage and whatnot. This is incredibly powerful, and in water, at USGS, we're asking, what is our Did You Feel It, but for water? What is our killer crowdsourcing citizen science app for the basic collection of water data? To my knowledge, we don't know yet. Moving up the hierarchy, to the right, whatever. We're now standardized. So there have been some questions already about interchange formats, common formats. We can't seem to agree on them. Again, a lot of gaps. Let's talk about a success story. Let's talk about a place where two or more agencies, through something like the Open Geospatial Consortium, have agreed upon a common language to talk between each other. We have WaterML and the Water Quality Exchange. Just two examples of formats that have achieved some degree of wide acceptance in the water sector for interchange. Doesn't say anything about how you store the stuff internally. It says how do you talk about it machine to machine. And I don't expect anyone to read or parse all of that there in a brief time, but if you think that a spreadsheet is a useful interchange format because it's human eye friendly, that's the way things used to be. But trust me, this type of format here is much more machine friendly in terms of interchange. It's richer, has a lot more potential. So we do have some emerging successes in the realm of standardizing, which is starting to take that basic data and bring it together to say something larger. By coming back to everyone's favorite, the thing that apparently I'm picking on this morning, because we need so much more, there is a gap with groundwater data at the level of standardization. We have here something called the National Groundwater Monitoring Network. Again, a fairly recent endeavor that's been undertaken, and the observation was groundwater data, well, there's more of it out there if you just look at all the various entities that can collect it. USGS has no business in a lot of states collecting any of it. It's a state purview, sometimes a water authority purview. And so we've been working on having an interchange, common language, water ML, where any agency, we have 16 right now, can participate. And then you have an aggregate view of that at the standardization level. But of course the gap is you need more agencies. And of course, teaching your systems to talk that language is not necessarily an easy task, especially for a smaller agency. It's a very difficult task. Water use, another gap. We've already heard about water use at that basic data level, but at the standardization level, at the bringing it all together, we know that there is a gap here because water use is such a state-by-state, eastern versus western United States, very diverse phenomenon. There was an article in the New York Times by Charles Fishman earlier this year that was a distinct call to action. It started with an indictment of why is no one doing this? How could a country not know how much water it's using? And he said, well, we should. Don't know where that's going, but I thought I would at least call out the article as something that you can look up. And just to give a really fine point, a specific example on that, reservoir storage, right? So man-made lakes. There is no national aggregation, no national common language for the amount of water stored in reservoirs, which a huge amount of our fresh water is stored in. Now, you just saw a few minutes ago, there are remotely sensed products that will tell you the surface extent of a lake, but you also need the bathymetry of it to get its storage. So, but how much water is in storage nationwide in our reservoirs is a good question, and there's a gap. But you have to proceed carefully on this. So, I already told you one humbling experience in my life. Another humbling experience was a little component of my master's thesis at the University of Texas. We thought it'd be a great idea to try to aggregate some water data from a lot of different agencies to say something really big about the Edwards Aquifer, limestone aquifer in Texas. It's major, well, for San Antonio, it's big potatoes, very big deal for them. Well, in the course of doing it, I learned firsthand with a lot of headaches that were medicated with Anacin about the problems of duplicate data. I copy your data, I put it in my database, and you can just send back to me, and ad infinitum, different formats, really different data quality with no encoding of the data quality. The way this agency A collected a nutrient sample in a bottle and held it for 2 weeks in their truck versus agency B, which collected it and processed it immediately after filtering it, can create apples to oranges problems that are not easy to resolve. And I don't know exactly what came up with this full analysis. I've moved on to other things, but it seemed to me like the only real interesting or informative product was just a map showing dots on the map where there were and weren't data. And turns out people who already knew the area well said, yeah, well, of course, yeah, Western Bayer County, no data. Yeah, this is not revelatory. You didn't learn anything new. So when you standardize, you have to do it thoughtfully. What can we do? I just thought I would mention the name of this. It's a brief, don't have a lot of time. The Open Water Data Initiative is another relatively recent endeavor, but so far it has not been funded at the federal level. It's mostly professional volunteerism within organizations. But it's more about this interchange, at least at the federal agency level, Open Water Data Initiative. So we get then to the highest level of this whole hierarchy, integration. Once you've brought the data together, what can you say about it? You have big data, congratulations, now what? How does it become actionable? And I put this diagram up here just to remind us on a philosophical level that the reason this is important for water is there is only one water cycle. There is a continuity, there is a wholeness. When I show this to elementary school classrooms, I put a picture of a dinosaur up there. They tell them you're drinking dinosaur water. Well, that's true. So water is a perfect example of the need for integration. The more you can think about the whole and the less about the part, the wiser your decisions will be. But there's not a lot of integration going on here yet. There's a lot of things underway, but my examples, my success story has to be fairly modest. US and Canada have at least come up with North America Water Watch. This is just one step above standardizing. You can at least see the monitoring locations and current statuses of surface water phenomena in 2 countries now. Just one example, there are many others. The USGS and EPA have partnered to create the Water Quality Portal, talks a common language. You can see a wider view. These 2 major information collectors, you can get discrete laboratory sample data from both of them seamlessly. But there's some more integration work to do after that to make it actionable. Another gap, which I've just been wrapping my head around because it's almost at the level of philosophy. It's connecting the really big with the really small, which was touched on already here. But so GRACE is a satellite program that looks at gravity measurements, small changes in gravity, and it turns out you can talk about groundwater resources with GRACE. It's amazing. But it is a super regional, almost continental scale analysis, big picture, as that water changes mass in the ground. But meanwhile, as you see on the right here, agriculture very often is local. GRACE cannot answer the question of, will my pump turn on and find water at the bottom of my center pivot irrigation this morning? So tying those things together is a big part of integration. Not well solved yet. But there is one anecdotal piece of something I'm especially glad that I got to work on. This is from Arizona. Just a very reductive, simple example. In the Grand Canyon, there is a huge management question of how much water to let flow through it, from Glen Canyon Dam at the upper end to Lake Mead at the lower end, our second and first largest reservoirs in the country. And sand, as it moves through there, is a huge ecosystem and human recreation issue. A lot of monitoring, a lot of data, a lot of standardization in the Grand Canyon, but the decision makers, the stakeholder group, asks the question, can we do a high flow release? And you see just a diagram here from January of 2016 up until mid-November. And this is taking thousands of laboratory samples, millions of individual data points, all of this, and reducing it down to a single actionable time series graph that shows in a reach of the river how much sand was gained or lost. And so there's a slow loss of sand in this reach going to the right, and then summer storms spike, there's an influx of it, and by the time you reach the far right of this graph, they say there is now enough mass of metric tons of sand in this reach to do a high flow experiment. It released a lot more water to move that sand down the river, and you can just see the beginnings of it dropping off there at the right. This is creating actionable, decisionable information out of raw data, making the big data smaller. And I'll just leave you with this, and then hopefully time for some good conversation, because I want to hear what you all think. The national water model is something that is starting to come on the line. It's in the early stages of understanding, but the ambition, the vision at this point really is that next generation forecasting of the hydrosphere, certainly weather, as we all care about, in the atmosphere, but also unmonitored locations on rivers. And I can't get into any more detail than that because I'm still learning about it, but it needs to integrate as much data from diverse sources as possible to answer a very societally relevant question about our hydrosphere. So with that, I'll end the presentation. We've collected, standardized, integrate, and hopefully we can discuss a little.